Hello friends, let us discuss about periodic function. Suppose we have a function f of x which is equal to sin x and let it be y. So, if you draw the graph, here it is x-axis and this is y-axis, which is sin x, right, value of sin x, and this is the 0 and here it is pi by 2, 3 pi by 2, sorry, it is pi and 3 pi by 2 and then twice pi, right? So if you put the values of sine, if you put x is equal to 0, then as value of sine 0 is 0, and if you put x is equal to pi, it's gonna be 1, sorry, not 1. If you put pi by 2, x is equal to pi by 2, at x is equal to pi by 2, sin x is 1, and at pi it's 0 again, and at 3 pi by 2 again it will be minus 1, right? And at twice pi it is 0. If you draw the graph, if you join these dots, then you will get this graph of sine function. And here you can see we are getting sin x is equal to 0 at 0, pi by pi and twice pi and so on. So at these points, at those points, the sin x is repeating, value of sin x is repeating after interval pi. So here you see, as the value of sin x is repeating after a certain interval, that's why it can be it can be said as a periodic function, okay, with period pi. So values of sin x, right? So values of sin x is repeating after interval pi. After interval pi, so sin x is a periodic function with the period t is equal to with the period pi. So hope you have understood this. So now suppose f of t be a periodic function, with the period t, then its Laplace transformation is given by Laplace transformation of f of t is 0 to t e to the power minus st f of t dt divided by 1 minus e to the power minus s capital T. So capital T is period here. So that's using this formula we can find a Laplace transformation of a periodic function. So let me prove this formula. So proof of this formula is, by definition, we know the Laplace transformation of a function f of t is given by 0 to infinity, integration 0 to infinity e to the power minus st f of t dt, right? F of t dt. So here from 0 to infinity we're gonna divide these intervals into small intervals, 0 to t, then t to capital 2t, then 3 capital T, and so on up to infinity, right? So then this Laplace transformation of this function f of t becomes like this. You will get these things, okay, 0 to t, then again e to the power minus st f of t dt. So f of t dt, here f of t dt, then t to twice t e to the power minus st f of t dt, and so on. So that's how you will get this way. So then we're going to substitute t is equal to u plus capital T in the second term, then in third term u plus 2 capital T, and in the third term, and so on. We're going to do substitution, right? And if you differentiate t is equal to u plus capital T with respect to small t, differentiating this with respect to small t, that's you're gonna have du is equal to dt, right? So that's what we're gonna have. So now what we're gonna do, so let me move on to the next slide. Here Laplace transformation of this function f of t is 0 to t e to the power minus st f of t dt, and then plus again 0 to t e to the power minus su plus t f of u plus t du, right? After substitution, this we will get after substitution u, as I have mentioned in the previous slide. So what I have substituted, small t is equal to u plus t in the second term, in the third term small t is equal to u plus capital 2t, and so on, right? And doing so, what we have got this result. So as you can see, f of t is a periodic function. It is a periodic function. So that's why what you're going to have, So therefore f of u will be equal to f of u plus t, as t is the period, and if it is a periodic function, after this period it's gonna give you the same value. So we know, as we have taken as example in the first slide, that sin x. So after the period pi, we are getting the same value 0 0 again. At 0 we had got 0, at pi we had got 0 again. After one more pi, that is twice pi, again we had got sin x is equal to 0, isn't it? So that is why, so f of u will be equal to f of u plus t, where t is the period, and then again f of u plus 2 capital T is also give you the same value, and so on, right? So that's why this results here, you see, we can write this one f of u, this one also f of u, we can write this, and here you see e to the power minus s u plus t, u plus capital T, this can be written as e to the power minus s u in dot into, that means e to the power minus s capital T, right? So we can do this thing, so we can consider here u as variable and e to the power minus s capital T as constant. So that's why our results become this way: 0 to capital T e to the power minus s small t f of t dt, and plus e to the power minus st is taken outside of the integral, then again 0 to capital T e to the power minus su f of u du, and e to the power minus 2s capital T, and then 0 to t e to the power minus su f of u du, and so on, right? So now what we're going to have here, here you can see f of u, and u is a dummy variable, so we can replace u by small t, and doing so we have got this result. So let me write the result: replacing u by small t, right? So you're gonna get this result, and yes, plus, okay, so we're gonna get this result. So now here you see, we're gonna take this term common. Here you see 0 to capital T e to the power minus st f of t dt, you can take this common from each term, and doing so what we have got, Laplace transformation of the given function f of t, this is the periodic function, we have got this, and right, so yes, so 0 to capital T e to the power minus st f of t dt is taken common, right? So within bracket we have left with 1 plus e to the power minus st, e to the power minus 2 st, e to the power minus 3 st, and sum of this series is given by, so 1 plus e to the power x, you can if you remember this series, 1 plus e to the power minus x, e to the power minus twice x, plus so on, and sum of this series is given by 1 by e to the power 1 by 1 minus e to the power minus x. So we're going to use this result here. So then this series, sum of the terms of the series within bracket gives you, first let me write the integral part, okay, then the series is going to give you this, right? So that's how we're going to prove. So what we have done, we have used this result, here, okay. So here minus x is nothing but minus st, right? So using those we have got 1 minus e to the power minus st, and if you multiply this result with this integral, you're gonna get this. So this is the required formula, and that is proved. That's how we're gonna find Laplace transformation of periodic function using this formula. So now let us solve some problems. So let's move on to the next slide. Now let us solve this question. We need to find the Laplace transformation of this function f of t e to the power t for t is equal to 0 and t greater than 0, less than 2 pi. Okay, so how to find the Laplace transformation of this function? So let me write the given function first, f of t e to the power e to the power t for the interval t greater than 0, less than 2 pi. Here 2 pi gonna be the period of this function. This is a periodic function. So Laplace transformation of periodic function, we know the formula, that is given by 0 to capital T, which is period e to the power minus st f of t dt, and divided by 1 minus e to the power minus s capital T. T is the period. So if you put the periods and the function, so we're gonna get this result. Okay, so what we have got this. Okay, e to the power minus 2 pi s, right? We have put the period t is equal to 2 pi here. You see, let us replace this f of t. So f of t is equal to this function e to the power t. So let us use this here. So then we have got this result, 0 integration 0 to 2 pi e to the power minus st. F of t is nothing but e to the power t dt, and divided by 1 minus e to the power 2 pi s, right? So now let's move on to the. So now you see here we can multiply these two. So it's gonna give you, if you multiply these two, e to the power minus st plus t, right? So now using this product here, so we're gonna have 0 to 2 pi e to the power minus st plus t dt, 1 minus e to the power minus 2 pi s, and taking t common, so we have got this result, e to the power minus s minus 1 t dt by 1 minus e to the power s 2 pi, 2 pi s. Then integration of this e to the power minus s minus 1 into t dt. So if you integrate, you will get minus 1 by s minus 1 and e to the power minus s minus 1 into t again. So now we are integrating from 0 to 2 pi. Okay, now let us put the upper limit and lower limit, then subtract. So if you put the upper limit, then you're gonna have this e to the 1 by minus 1 by s minus 1 e to the power minus s minus 1 into 2 pi. This is upper limit, and putting the lower limit, what we got, e to the power minus s minus 1 into 0. That's what we will get. So here you see, so the final result we can have e to the power minus s minus 2 pi, and this is going to be e to the power 0, that's going to be 1, right? Anything to the power 0 is 1. So now let us use this value here. Let us use the value of this integration here. So we have got this result, right? So using the integration, so this is the Laplace transformation of the function f of t, right? So if you simplify this, then what you will get. So this is the result after simplification. So here this is this should be written 1 minus s. So as this this minus is multiplied here, if you multiply both the numerator and denominator by minus 1, that's you're gonna get this result. So this is the Laplace transformation of the given function f of t, where f of t is e to the power t, right? And this is a periodic function, and where for t is greater than 0 less than 2 pi, right? So 2 pi was the period. So that's how we can find the Laplace transformation of such function. Now we need to find the Laplace transformation of this function f of t sine omega t. T is greater than 0 less than pi by omega. So here the period is pi by omega. So let me write the given function, that is f of t is equal to sine omega t for t greater than 0 less than pi by omega. Here capital T, that is period, is pi by omega, and according to the formula of Laplace transformation of periodic function f of t is 0 to capital T e to the power minus st f of t dt divided by 1 minus e to the power s capital T, e to the power minus s capital T. So here capital T is nothing but pi by omega. So f of t is sine omega t, right? So if you put those here, this integration 0 to pi by omega e to the power minus st, f of t is nothing but sine omega t dt, and divided by 1 minus and if you put a value of capital T, that is period, pi by omega, then you will get minus s pi by omega, right? So we gonna use this formula here to find the integration of e to the power ax sine omega sine bx dx is equal to e to the power ax and a sine bx plus b minus b sine bx divided by a square plus b square. Okay, so here our a gonna be equal to, if you compare these two, our a gonna be equal to minus s, b gonna be equal to omega. So a is minus s, b is omega. That's what we got. So using this formula, we got the integration e to the power minus s t sine omega t is equal to this. So this is the result. After integration, we have got this minus s e to the power minus s t into minus s sine omega t minus omega cos omega t and divided by s square plus omega square. That's what we have got. Okay, so now we are integrating from 0 to pi by omega, isn't it? So this is Laplace transformation of f of t. So we are integrating from 0 to omega. So Laplace transformation of this. So finally we have got this, right? So let me rewrite this. Okay, s square omega square. Okay, so now this is integration from 0 to pi by omega. So if you put the upper limit and lower limit and subtract the results, then first let us put this pi by omega. So if you put this first, then what you will get? Then we will put 0. Okay, then we will subtract. Let us put pi by omega first. Then putting that, we have got the numerator here, this. Okay, so here again minus. Now put the lower limit, that is 0, and e to the power 0 s sine 0 minus omega cos 0. Now here you see sine pi is 0 and cos pi is equal to minus 1. So here it will be e to the power minus s by omega, and then here you see minus 1, that's going to be again here you see this thing. Let me show you. So as we have got minus 1 here, cos pi is minus 1, so that's why minus omega minus 1, that's going to be plus, right? And then sine 0 is 0, so e to the power 0 is 1, anything to the power 0 is 1, then cos 0 is 1. So here minus, here also minus, this sign becomes plus, so omega. So that's what we have got, right? So taking omega common, we have got this e to the power minus pi s by omega plus 1, right? We have got this. Now using this value here, we have got the result. We have got this result. So let me write this result. Okay, so we have got this result. So now what we can do? So now you see, let us multiply e to the power pi s by 2 omega with the both numerator and denominator. Then this result gonna be equal to, this is gonna be equal to omega by s square plus omega square into, if you multiply here, you will get 1 into e to the power s by 2 omega, that e to the power pi s by 2 omega. Then if you multiply with the e to the power minus pi s omega into e to the power pi s by 2 omega, then you're gonna have e to the power minus pi s by 2 omega, right? So similarly in the denominator, if you multiply this, then you're gonna have this result. So let me write the results. Okay, so you're gonna have this. So now this is equal to nothing but cot hyperbolic pi s by 2 omega. Okay, pi s by 2 omega, it is a formula. So then using that result, we have got this cot hyperbolic pi s by 2 omega. So this is the Laplace transformation of the given function. That's how we can solve. So hope you have understood this. Now let's move on to next slide. So we need to find the Laplace transformation of this. Let me write the given function. Here f of t is t square for t is greater than 0 less than 2, and f of t plus 2 is also equal to f of t. So this represents nothing but f of t is a periodic function, that's all. So here t is the 2, period is 2 here. So Laplace transformation of f of t and Laplace transformation of a periodic function is given by this formula: 0 to capital T integration 0 to capital T e to the power minus st f of t dt divided by 1 minus e to the power minus s capital T, right? Capital T is period. So it's gonna give you, if you put the capital T value of capital T, that is equal to 2, and value of f of t, the function is t square dt, then if you replace the capital T by 2, then you will get here e to the power minus 2s, and integration of t square is n e to the power minus st dt. So here we using Eilert, according to Eilert, so exponential function should be considered second function, and the algebraic should be considered as first function. First, this is algebraic, this is exponential, right? So then using the product rule, we're gonna get this result, right? So this is the integration, right? So if you integrate again, here it is, derivative of t square is, we know that 2t, so and it is equal to, right? So that is the integration. I hope you know this simple integrations, so just I have written the result. So now t square by e to the power minus st by minus s plus 2 by s integration. Then again here you should take t as first function, then integration e to the power minus st, that gonna be considered as second function dt, minus again dt of t is 1, okay, then into e to the power minus st dt, right? So again by integration, what we will get? So after integrating all this, we have got this result. Let me write the result directly, okay? So I hope that you know the integration well. So this should be right. So this is going to give you this result, okay? Okay, so we have got this result after integrating, right? So now integration of t square e to the power minus st dt is equal to, we have got this result. Let me write the result here. So this is the result. Now we are integrating from 0 to 2. Now if you put the upper limit and lower limits here in each term, then putting those values 2 first, then we have got this, then again putting 0, putting 0 in each term, we will get 0, that's why we are neglecting that, okay? So after putting the limits, we have got this result. So here you see, in each term we have t square, t, and at the end, at the last term, we have e to the power minus st and s cube. So if you put 2 here, then you will get 2 e to the power minus st by s cube. Then if you put 0, then you will get 2 by s cube. So that's why after taking LCM, we have got this last term, right? So now what we have got, after taking LCM and after simplification, these are some very simple simplifications. Being the student of graduate or postgraduate, you should know the such kind of simplifications. That's it. So let me rearrange this result. Let me rearrange these results. So that is what we have got. Laplace transformation of f of t is equal to this, isn't it? F of t 1 minus t. So here this result is the result of this integral part, 0 to 2 e to the power minus st f of t. F of t is here t square, right? So if you put this result here, then you will get the final result, okay? So now you see here, let me tell you one thing. So I hope you have understood this result. So first we have put here 2. After putting 2 in this term, we have got this result. If you put 0 here, then it will be 0. So this is minus 0 again, this result. So similarly here also, if you put 0, you will get 0. That's why when you have put 2 here, then you have got this result, then minus again 0. So hope you have understood. And here putting 2, we have got this part. Then putting 0, we got this plus 2 by s cube, and this minus is taken common. That's why we have got this result. So hope you have understood how to put upper limit, lower limit, and how to subtract those things. You know, I hope that. And this is after simplification, we have got this integration 0 to 2 t square e to the power minus st, right, dt. This is the value of this integration. So now here you see Laplace transformation of f of t. So here what we have done, so this is the result. So let me show you one thing. So this is the value of this integration only. So if you put here, then you will get the Laplace transformation of this function. So let me rewrite. So this is the result of Laplace transformation of the given function f of t, which is t square, right? So this is the result we have got. So hope you have understood this. So now here you see, let us solve this Laplace transformation of this f of t cos omega t and 0 for these two different cases. For one case, t greater than 0 and less than pi by omega, f of t is cos omega t, and otherwise it's 0. When t is greater than pi by omega and less than 2 pi by omega, so f of t is 0, right? So let us solve this. So first let me write the given function here. So this is the given function, right? So here 2 pi by omega should be the period, and Laplace transformation of a periodic function is given by this formula. So let me write the formula. This is the formula, right? So this is the formula to find the Laplace transformation of a periodic function. So here capital T is 2 pi by omega. We're gonna take this one as a period, and if you put the period here, and here you see putting this period. So as there are two cases, in one case cos omega t, in other case that is 0. So that's why this is split into these two results. So hope you have understood this, right? So here you see, so this same thing, there are two cases, isn't it? For 0 to this one, t greater than 0, pi by omega. So here when we have taken 0 to pi by omega, we have written here cos omega, and for this case 0, we have written here 0, from pi by omega to 2 pi by omega, right? So and the denominator is nothing but 1 minus e to the power minus, if you put 2t here, then you will get minus 2 pi s by omega. So this has become 0, right? This is 0. So now we have this part only, the Laplace transformation of this, right? So here Laplace transformation of f of t, that is the given periodic function, we have got 0 to pi by omega e to the power minus st, that is cos omega t dt, divided by 1 minus e to the power minus 2 pi s by omega. That's what we have got, right? So now integrate this, integration of e to the power x cos bx dx. It is a formula, remember this formula, very important formula. E to the power x by s square omega into a cos bx plus b sin bx. Okay, so here this is a, this is b, a is minus s, b is omega. So using these values, so we're gonna get the integration e to the power minus st cos omega t dt. Its integration is this, e to the power minus s by s square plus omega square, right? So here just 1 minute, just okay. So here for a and b, I should write here a square and this is b square. Okay, so here a is minus s b is omega. So formula is this, a square b square. So a is replaced by minus s, so a square will be minus s square, means plus s square, right? So that's what we have done, right? So sorry for the mistake. So now let me continue. So here what we have got, this is the integration that we have got using this formula, right? So now if you put the limits here, 0 to pi by omega, so we are integrating from 0 to pi by omega. So let's put the upper limit first. If you put the upper limit, that is pi by omega, you will get this result, e to the power minus pi s by omega by s square plus omega square into minus s omega. So here when you will put t is equal to pi by omega, so omega will be gone, so you will get cos pi, and similarly here you will get sin pi, right? Omega sin pi, that's what you will get. So minus, then put lower limit, e to the power 0, that's going to be 1 s square omega square. So putting 0, you will get s sin cos omega 0 and sin 0 also. So we know cos pi is minus 1, so minus 1, and sin pi is 0, so sin 0 is also 0, and cos 0 1, right? So here you see, using this result, this is going to give you this is minus 1 minus s, that's going to be positive s, and you're going to have s e to the power minus pi s by omega by s square plus omega square. And here you see this is minus 1 into s minus s, and then again it is minus, e to the power 0 is 1, then minus minus is going to be plus. So we have got this result. Now taking this part common, let us take this part common. So this is suppose equation number 1, okay? This is suppose equation number 1. Now let us write the result of this integration. This integration is equal to, so let me write here dt, okay? This integration is equal to, we have got, taking s by s square plus omega square common, we have got within bracket e to the power minus pi s omega by by omega plus 1. Then the Laplace transformation from equation number 1, we have 0 to pi by omega e to the power minus st cos omega t dt divided by 1 minus e to the power 2 pi s by omega. This is from equation number 1. If you put this value of integration here, then you're gonna get this result. S into this can be written as this e to the power minus pi s by omega plus 1 can be rearranged as this 1 plus e to the power minus pi s by omega, right? So below it that means the denominator s square omega square into 1 minus this denominator 1 minus e to the power minus 2 pi s omega can be written this way, in this form, right? And writing in this form, we're gonna apply a square minus b square formula, that is equal to a plus b into a minus b, right? So if you apply that, then here we will get 1 plus e to the power minus pi s by omega into 1 minus e to the power minus pi s by omega. So here these two will be cancelled out each other, so our final result is this. So this is our final result. So this is the Laplace transformation of the given function. So that's how we can solve. So hope you have understood. If you like my video, hit the thumbs up button. If you are new to my channel, just subscribe the channel, and if you like my video,